Hey guys, tonight we are traveling to a place where the rules of nature have been turned upside down. A real-life lost world. Imagine, we are standing on the edge of a dense tropical jungle. The air is thick, humid, and alive with the buzz of insects you've never heard before. Before you lies an island, a green jewel set in the turquoise water of the Indonesian archipelago. It is a place that has been isolated from the rest of the world for millions of years. A living laboratory where evolution decided to run some of its strangest experiments. This is the island of Flores. As you step into the gloom of the forest, you notice that everything is slightly off. In this strange world, giant dog-sized rats scuttle through the undergrowth, and through the trees you see a herd of elephants. But they are no bigger than ponies. Life here has been rewritten. But it's not just the animals that are different. Something else lives here, hiding in the shadows of the limestone caves. Something that looks almost human. Something that connects this bizarre, forgotten world directly to us. Over hundreds of thousands of years, this creature adapted to this strange place. It shrank. It learned to hunt the dwarf giants and hide from the oversized monsters that stalked the island. It became a different kind of human, a lost branch of our own family tree. So how could a human species become so small? What was their world really like? A world of dragons and dwarf elephants? And could the haunting stories told by the modern inhabitants of this island, tales of small, hairy forest people, actually be a distant 50,000-year-old memory of them? Thanks to a remarkable discovery in a cool, quiet cave, tonight we will venture into this lost world together to find the answers. Frankly, if you were dropped here 100,000 years ago, your main contribution to the ecosystem would be as a conveniently packaged, high-protein snack for a 10-foot lizard. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. That small click sends a big signal to the algorithm. That long-form, serious educational content still matters. And to me, it's an incredibly meaningful show of support. Thank you so much for helping keep this channel going strong. It always fascinates me to see where you're all tuning in from. Let me know in the comments where you are in the world and what time it is for you. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Your journey begins not with a step, but with a map. You look at the sprawling cluster of islands that make up modern-day Indonesia, a splash of green between the grand land masses of Asia and Australia. For much of history, this region was a biological puzzle. The great 19th century naturalist Alfred Russel Wallace, a contemporary and friendly rival of Charles Darwin, spent years here. He noticed something peculiar. As he traveled from island to island, he saw that the animals on one side of an invisible line were clearly Asian in origin. Tigers, rhinos, monkeys, while the animals on the other side were Australian, marsupials like kangaroos and strange egg-laying mammals. This invisible biological barrier became known as the Wallace Line, and you find yourself standing right in the middle of it, in a unique transitional zone called Wallacea. The island of Flores, whose name is a slightly ironic Portuguese word for flowers, is a key piece of this zone. It's a rugged volcanic island, a place of sharp peaks and deep valleys. But its most important feature isn't what's on it, but what surrounds it. Incredibly deep water. This is the scientific evidence that underpins the island's entire strange story. Even during the peak of the ice ages, when so much of the world's water was locked up in glaciers and sea levels dropped by hundreds of feet, creating land bridges between places like Asia and Borneo, the trenches around Flores remained stubbornly full. It was always an island. There was no walking here. Any creature that wanted to call Flores home had to make a perilous sea crossing, probably by accident, swept out to sea on a raft of tangled vegetation during a tsunami or a monsoon. This isolation is the secret ingredient. It turns an island into a crucible of evolution, a place where the normal rules of competition and predation are thrown out the window. For any creature lucky, or unlucky, enough to make the trip and survive, the island presented a strange new reality. Limited space, limited food, and a limited cast of characters. The top predators from the mainland, like tigers or leopards, never made the crossing. The vast herds of grazing animals were gone. It was a blank slate, and life, as it always does, began to adapt in the most extraordinary ways. You are standing in a world where the very concept of big and small has been renegotiated by nature itself. This isn't just a different place, it's a different reality operating on a unique evolutionary clock, and it's in this isolated, otherworldly landscape that our story truly begins. This strange evolutionary clock you're witnessing, this renegotiation of size and scale, isn't just a random fluke. It's a recognized pattern, a predictable piece of biological magic. In the 1960s, a biologist named J. Bristol Foster was studying mammals on islands around the world and noticed this bizarre tendency. He formalized it in a famous paper, and it became known as Foster's Rule, or more simply, the Island Rule. The rule is elegantly simple. When you trap a group of animals on an island for a few thousand generations, big things tend to get small, and small things tend to get big. You are standing in a textbook example of this rule in action. Let's start with the big things getting small. This half of the rule is called insular dwarfism. Imagine a full-sized mainland elephant, a stegodon, an ancient relative of the elephants we know today. It's a colossal creature, needing vast amounts of food every single day to power its massive body. Now, imagine a handful of these giants get swept out to sea and wash up on the shores of Flores. At first it's paradise, no tigers, no major predators. But soon the reality of island life sets in. The forests are dense, but they're not the endless plains of Asia. Food is limited. In this environment, being huge is no longer an advantage, it's a liability. The largest elephants, the ones who need the most food, are the first to struggle and the least likely to reproduce successfully. The slightly smaller ones, the runts of the litter who would have been outcompeted on the mainland, suddenly have an edge. They need less food, they can navigate the dense jungle more easily, and they can survive a lean season. Over thousands of years, this pressure continues. Natural selection consistently favors the smaller individuals. Generation after generation, the species shrinks. The fossil record on Flores shows this happening with stunning clarity. The original colonists, Stegodon trigonocephalus, were giants. Their descendants, Stegodon floresiensis, were dwarves. As you peer through the trees, you see them. Herds of elephants that stand no taller at the shoulder than a large boar, some weighing only a few hundred kilograms. It's a sight so strange, it borders on the unbelievable. A miniature echo of a bygone world. This process isn't unique to Flores. By the way, on the ancient Mediterranean islands, dwarf elephant skulls were once a common find. Some historians now argue their skulls, with the large, single nasal opening right in the center, may have been mistaken by ancient Greeks for the skull of a one-eyed giant. giving birth to the legend of the Cyclops. Islands don't just create strange creatures, they create the seeds of myths. Now you turn your attention from the trees to the forest floor, and you see the other side of Foster's rule at play: insular gigantism. Back on the mainland, small creatures like mice and rats live in a state of constant terror. Everything wants to eat them. Cats, snakes, birds of prey. Their evolutionary strategy is to be small, fast, and to reproduce as quickly as possible before they become someone's dinner. But on Flores, most of those predators are gone. For a rat, it's a land of opportunity. The pressure to stay small and hidden vanishes. Now, the advantage goes to the bigger individuals. A larger rat can fight off rivals for food. It can store more fat for lean times, and it can have larger, healthier litters. With the brakes of predation taken off, evolution hits the accelerator. The rats get bigger and bigger. You see one scuttling out from under a fern, and you freeze. This is not the kind of rat you've ever imagined. This is Papagomis, the Flores giant rat. It's the size of a small dog, with a thick, powerful tail and long yellow teeth. It moves with a confident, unhurried gait, utterly fearless. It is the king of the forest floor. Biologists still argue about the precise selective pressures that drive these changes, but the general pattern is undeniable, creating an ecosystem that feels like a fantasy novel. Dwarf elephants, giant rats, and as you'll soon see, monstrous birds. It is a world turned inside out, and it begs a profound question. This rule, this twisting of life's blueprint, clearly applies to elephants and rodents. But what happens when the creature that washes ashore is a hominin? A creature that stands on two legs, has a large brain, and carries the spark of ingenuity. What happens when a human gets trapped by the island rule? The answer to that question, the question of what happens when a human is subjected to the island rule, wouldn't be found by studying a living creature. It was found buried under 15 feet of earth and rock, in a place that had held its secrets for 50,000 years. Your journey now takes you inland, away from the coast, climbing into the rugged limestone hills near the Rakang River. The air, once thick and humid in the jungle, becomes noticeably cooler as you approach a gaping mouth in the side of a cliff. Locals call this place Leang Bua, which simply means the cool cave. The name is an understatement. As you step out of the tropical sun and into the immense shadow of its entrance, a wave of cool, damp air washes over you. It's a natural air conditioner, a welcome relief from the oppressive heat. The entrance is colossal, over 160 feet wide, a grand archway sculpted by water and time. The cave is less a simple hole in the rock, and more a limestone cathedral. Sunlight slants down from the high ceiling, illuminating a vast chamber that could comfortably house a dozen school buses. The floor, a wide, flat expanse of reddish-brown earth, stretches back into the gloom. You can hear the drip, drip, drip of water seeping through the rock, each drop echoing in the profound silence. This place feels ancient, a natural fortress that has offered shelter from monsoons and predators for longer than humans have been writing things down. Even today you might see local farmers ducking inside to wait out a sudden downpour, a quiet continuation of a tradition that stretches back into the mists of prehistory. For an archaeologist, a place like Leang Bua is a treasure chest. A cave is a natural trap for history. For millennia, anything that lived, died, or was left behind in this chamber was gently covered by the passing of time. Dust settled. The river flooded and deposited layers of silt. The limestone ceiling crumbled, adding its own fine powder. The floor you're standing on isn't the original floor, it's just the top page of a thick, layered book. Each layer, or stratum, is a snapshot of an era. The deeper you dig, the further back in time you travel. This principle of stratigraphy is the bedrock of archaeology. Here, in the cool, stable environment of the cave, bones, tools, and ancient charcoal are preserved with remarkable clarity. You could sink a shovel into the ground and bring up the remains of a meal cooked 1,000 years ago, 10,000 years ago, or, as scientists would soon discover, much, much further back than that. It was this potential that drew a joint team of Australian and Indonesian researchers here in the early 2000s. The project was co-led by an ambitious Australian archaeologist named Mike Morwood and a revered Indonesian expert, Raden Soejono. They assembled a dedicated team to painstakingly excavate squares of the cave floor, scraping away the dirt layer by layer, sifting every handful for a clue. But you need to understand, they were not looking for a lost species of human. Their goal was, in their minds, completely different. They were seeking answers to one of the most debated questions in human prehistory. Precisely when and how did modern humans, Homo sapiens, first reach the continent of Australia? It was a known fact that people had to have crossed the sea, hopping from island to island, and Flores was a logical stepping stone on that epic journey. The team at Leang Bua was looking for the campsites, the tools, and the graves of our direct ancestors, hoping to piece together the final stages of humanity's grand march across the globe. They had no idea that the story buried beneath their feet was not about our own species, but about a mysterious cousin they never even knew existed. They were about to accidentally rewrite a major chapter of the human story. For 2 years, the work in Leang Bua had been a slow, patient grind. An archaeological excavation is not a treasure hunt. It's a meticulous, almost meditative process of deconstruction. Imagine the scene. It's September 2003. The air in the cave is still and cool, a sharp contrast to the blistering heat outside. The only sounds are the scrape of trowels against the earth, the soft whisk of brushes, and the rhythmic shaking of sieves. You're watching the team work in their carefully marked-out square pits, slowly, painstakingly, removing the soil centimeter by centimeter. Most days, their reward is a handful of stone flakes, a pig's tooth, or the bone fragment of a rat. They are mapping the past, but it's a slow and often tedious conversation with time. They are looking for the trail of our ancestors, but so far, the trail has been faint. Then, on this particular day, something changes. You're watching a senior local excavator, a man named Benjamin Tarus, working at the bottom of a pit nearly 20 feet below the cave's surface. He's carefully scraping at a dense layer of clay when his trowel makes a different sound. Not the grating sound of hitting a stone, but a dull, hollow thud. He stops. Experience has taught him to recognize that sound. Gently, he switches from his trowel to a small wooden pick, and then to a soft brush. He starts to clear the soil, and a shape begins to emerge. It's pale, rounded, and unmistakably bone. As he clears more dirt, the team above him gathers at the edge of the pit, looking down with a mixture of curiosity and professional focus. He reveals the curved dome of a cranium, then the delicate arch of an eye socket. It's a skull. The initial mood is one of quiet success. A human skull is a major find. The bones are incredibly small and delicate, leading to an immediate and obvious conclusion. It's the skeleton of a child. Perhaps this was one of the early Homo sapiens pioneers they had been searching for all along, a tragic glimpse into the harsh realities of prehistoric life. The team begins to work with renewed urgency and care, knowing they are now excavating not just a site, but a grave. They are expecting to find the unfused bones and unerupted teeth of a young child, a sad but scientifically straightforward discovery. But as more of the skeleton is revealed, the straightforward story begins to unravel. The project's lead paleoanthropologist, Peter Brown, is called over to examine the find more closely. You watch as he kneels down, his eyes scanning the bones with an expert's precision. He looks at the skull, the jaw, and then he focuses on the teeth. And that's when the first alarm bell rings. The teeth are wrong. They aren't the small, pristine teeth of a child. The surfaces of the molars are heavily worn down, ground smooth by years of chewing tough, gritty food. And then he sees the clincher. In the back of the jaw, the third molars, the wisdom teeth, are fully erupted and also show signs of wear. In any human, modern or ancient, this is an undeniable sign of adulthood. A wave of confusion ripples through the team. It's a moment of cognitive dissonance where two contradictory facts are warring for dominance. The evidence of the teeth says adult. The evidence of the skeleton's tiny, gracile size screams child. It's like finding a teacup-sized elephant or a lion no bigger than a house cat. It simply doesn't make sense, sparking a quiet, stunned debate right there at the edge of the pit. What could this possibly be? That night, in the research camp, the atmosphere is electric. The tiny, mud-caked skull sits in a special tray. The guest of honor at a conference of bewildered scientists. They have no answers, only a profound and thrilling mystery. They have found a creature that, by all the known rules of human evolution, should not exist. The days that followed that baffling discovery in the cave were charged with a new kind of energy. The slow, methodical pace of the dig was now infused with a sense of profound importance. You can picture the scene as the team, armed with the finest of tools, dental picks, bamboo slivers, and whisper-soft brushes, embarked on the painstaking task of liberating the rest of the skeleton from its earthy tomb. Every grain of dirt was treated as a precious clue. This was no longer a routine excavation. It was an exhumation of a secret history. The skeleton was given the official unromantic designation of LB1 for Leang Bua 1, the first of its kind. As they worked, the true significance of the find became more and more apparent. In the world of paleoanthropology, finding a single fossilized finger bone is cause for celebration. A jawbone can redefine a career, but LB1 was something else entirely. It was astonishingly complete. Slowly, the team unearthed a near-perfect skull and jaw, a remarkably well-preserved pelvis, an almost complete femur from one leg, along with shin bones, parts of the feet, arms, and hands. They had not found a fragment. They had found an individual. They could piece together a life. One of the most revealing parts was the pelvis. The shape of the pelvic girdle is one of the most reliable indicators of sex in a human skeleton, a direct result of the anatomical requirements for childbirth. The width and flare of the bones told a clear story. The tiny adult you're looking at was a female. This fact instantly gave the cold, scientific label of LB a new, more personal identity. She became known to her discoverers, and soon to the world, as the Little Lady of Flores. Like the famous fossil Lucy before her, Giving her a name made her feel less like a specimen and more like a person, a tiny, ancient ancestor with a story to tell. With a complete femur, the team could now move beyond just guessing her size. There are well-established mathematical formulas that link the length of the thigh bone to the overall stature of a walking hominid. It's a standard and highly accurate procedure. You can imagine the moment as Peter Brown took the measurement, plugged it into the equation, and stared at the result. The number that came back was stunning. The little lady of Flores, a fully grown adult female, stood just 1.06 meters tall. That's about 3 feet 6 inches. To put that in perspective, that's the average height of a modern 5-year-old child. All the pieces of the puzzle were now on the table. A human adult, with the teeth of a seasoned veteran of life, the body of a toddler, and a suite of other strange features they were only just beginning to uncover. When the team finally published their findings in the journal Nature in 2004, they gave their discovery a formal scientific name: Homo floresiensis. The announcement didn't just make waves, it triggered a tsunami. The initial confusion of the team in the cave exploded into a global academic war. The announcement ignited one of the most fierce and, at times, bitter scholarly debates in modern paleoanthropology. Instantly, 2 camps formed. On one side were Morwood, Brown, and their supporters, who argued that LB1 was the first example of a completely new, previously unknown species of human. On the other side was a powerful chorus of skeptics who insisted that the team had made a terrible mistake. This wasn't a new species, they argued. It was simply a sick Homo sapiens, a modern human whose tiny body and strange features were the tragic result of a terrible disease. At the heart of that fiery debate, one piece of the little lady of Flores became the central battlefield: her skull. For the skeptics looking to disprove the existence of a new human species, her tiny head was the perfect target. It was, by any measure, shockingly small. From the outside, you could see it was no larger than a grapefruit. But to truly understand the controversy, you have to look inside. You can't, of course, study a fossilized brain. Soft tissue like that vanished tens of thousands of years ago. But what you can study is the fossilized echo it left behind. The brain sits so snugly inside the skull that it imprints the bone with a faint but readable map of its own surface. The valleys, folds, and contours are all there. Using CT scanners and advanced computer software, scientists can create a detailed virtual model of the inside of the cranium. This model, called an endocast, is a ghost of the mind, a 3-dimensional blueprint of the brain that once powered the body. When the team created an endocast of LB1's brain, they were able to calculate its precise volume. The number they landed on was just under 420 cubic centimeters. To understand how radical that number is, you need some context. Your own brain, a modern Homo sapiens brain, is around 1,350 cubic centimeters. Our ancestor, Homo erectus, who was thought to be the most primitive hominin in this part of the world, had a brain of about 900 cubic centimeters. LB1's brain, at a mere 420 cubic centimeters, wasn't just smaller, it was in a completely different league. It was roughly the same size as the brain of a chimpanzee. For the skeptics, this was the smoking gun. How could a tool-using, upright walking creature be classified as a species of human if its brain was no bigger than an ape's? It seemed impossible. The simplest explanation, they argued, was that she wasn't a new species at all. She was a modern human who had suffered from a severe medical condition. The specific diagnosis they seized upon was microcephaly, a congenital disorder where an infant's brain fails to develop properly in the womb. Individuals with microcephaly have abnormally small heads and tragically, often suffer from a host of developmental and cognitive problems. The critics painted a picture of LB1 not as a member of a unique species, but as a pathological outcast from a population of normal-sized modern humans, whose strange anatomy was a symptom of her disease. It was a powerful and, on the surface, very plausible argument. But the Discovery team and their supporters fired back with a crucial piece of counter-evidence. They argued that the critics were so focused on the brain's size that they were ignoring its shape. They enlisted the help of a world-renowned paleoneurologist, Dean Falk. She took the endocast of LB1 and compared it not just to modern humans and other ancient hominins, but also to the endocasts of modern humans who had suffered from microcephaly. Her findings were a stunning rebuttal to the pathology theory. The endocast showed that LB1's brain, while tiny, was not the simple, underdeveloped or malformed organ seen in microcephaly cases. On the contrary, it was a highly complex and evolved brain. It was densely wrinkled and folded, a process called gyrification that packs more cortical surface area into a small space. It showed clear expansion in areas associated with complex thought. It wasn't a diseased modern human brain. It was something entirely different. A healthy, well-formed, miniature hominin brain that had been evolutionarily rewired for intelligence. The battle was no longer just about size. It was about organization. To prove their case, the scientists studying that ghostly endocast had to zoom in to focus on the specific geography of this miniature mind. Deep in the frontal lobes, just behind your own forehead, lies a patch of neural real estate known as Brodmann Area 10. You can think of it as your brain's CEO. It's not involved in basic functions like breathing or seeing. It handles the executive stuff. This is the part of your brain that engages in strategic planning, that weighs future consequences, that allows you to multitask and to deceive. When you're trying to decide on the best route through traffic, or planning a surprise party, or even telling a little white lie, your Brodmann Area 10 is firing on all cylinders. It's one of the key anatomical markers for what we consider higher human intelligence. And when paleoneurologist Dean Falk examined the endocast of the little lady of Flores, she found that her Brodmann Area 10 was enormous. Not just present, but massively expanded for a brain of that size. The brain may have been small, but it was apparently mighty where it counted most, dedicating a huge portion of its processing power to complex thought. This anatomical evidence was compelling, but it was still just a ghost in the machine. To seal the case, the team needed to connect this potential for intelligence with actual, real-world behavior. A big frontal lobe suggests a clever creature, but where was the proof? The answer, it turned out, was right there in the dirt, buried in the exact same layer of history as her bones. As the team widened the excavation around LB1, they found a treasure trove of artifacts that painted a vivid picture of her life and her capabilities. First, there were the stone tools. These were not just conveniently sharp rocks. You could see clear evidence of sophisticated manufacturing. They had found flakes, struck from a larger core with a single precise blow to create a razor-sharp edge, perfect for slicing through hide. They found points that could have been hafted onto wooden spears. They found heavier chopper tools, ideal for smashing bone to get at the nutritious marrow inside. Making a tool like this requires a whole sequence of complex actions. You have to select the right kind of stone, you have to understand the physics of how it will fracture, and you have to have the fine motor control to execute the plan. This was not the work of an ape. And then they found the hearths. Scattered throughout the cave floor were clear signs of controlled fire. And around these ancient campfires, they found the proof of what was on the menu: the charred and butchered bones of animals. There were the bones of the giant rats you met earlier, but there was something else too. The team found the unmistakable remains of juvenile Stegodon, the dwarf elephants. This was the final, stunning piece of the puzzle. Hunting and killing an animal, even a young one the size of a cow, is no simple task. It requires cooperation, communication, and a shared plan. It means working as a team to corner and dispatch a powerful and dangerous animal, then having the knowledge to butcher the carcass and the social structure to share the bounty. So now you can see the full, bewildering paradox of the little lady of Flores. On one hand, you have a creature with a brain no larger than a chimpanzee's. On the other hand, you have an archaeological record that shows this same creature making sophisticated tools, gathering around campfires, and coordinating to hunt elephants. The puzzle was only getting deeper. The evidence was clear. She thought and behaved like a human. But her body, as the team was about to discover, was even stranger than her brain. To truly understand the world of the little lady of Flores, you have to imagine how she moved through it. Her clever, rewired brain was housed in a body that was just as unique, a body built for a different kind of life. And the story of that body begins from the ground up, with her feet. When the team unearthed the foot bones of LB1, they knew they had something special. Feet are complex and delicate structures, full of small bones that tend to get scattered and lost over time. Finding a nearly complete set was an incredible stroke of luck, and they told a story that was just as strange as that of the skull. Imagine your own foot for a moment. It's an evolutionary marvel. The high longitudinal arch running from your heel to the ball of your foot acts like a powerful spring. When you walk or run, that arch compresses, storing energy, and then releases it, propelling you forward. It's what gives your stride its efficiency and its grace. The foot of the little lady of Flores had no such arch. It was almost completely flat. Furthermore, it was enormous for her size. Her feet were about 70% the length of her thigh bones. Yours are only about 55%. If you had the same proportions, you'd be shuffling around in a pair of natural clown shoes. This structure completely changes the mechanics of walking. Without that spring-like arch, every step is far less efficient, requiring more energy. Biomechanical models based on her bones reveal the kind of gait she must have had. To avoid scuffing her long, flat feet on the ground with every step, she would have had to lift her knees much higher than you do. It would have looked like a constant, high-stepped march. It was not a gait built for running or for graceful, long-distance trekking. It was a plodding, deliberate way of moving. Adding to the strangeness was her big toe, which was remarkably short. Another primitive feature, more like that of Lucy, the famous Australopithecus, than a more modern human. At first glance, this all seems like a disadvantage. A clumsy, inefficient walk in a world full of Komodo dragons and giant killer storks sounds like a recipe for extinction. But you have to remember the environment she was built for. You're not on the flat, open savanna where our own ancestors evolved their world-class running abilities. You are in the dense, tangled, and often muddy undergrowth of a tropical rainforest on a volcanic island. The ground is a chaotic mess of roots, rocks, and slippery leaf litter. Scientists still debate whether this unique gait was simply a primitive holdover from an ancient ancestor, or a specialized adaptation to the island's challenging terrain. In this context, her strange feet might have been a superb adaptation. The long, flat surface could have acted like a natural snowshoe, providing greater stability on uneven and soft ground. Her high-stepping, deliberate walk might have been the perfect way to navigate the cluttered forest floor with care and precision. She wasn't built to run a marathon, but she may have been perfectly designed to be a master of the Flores jungle. As you trace the body of the little lady of Flores upward from her strange, flat feet, the anatomy only gets more alien. Her entire upper body was constructed on a blueprint that deviates significantly from our own. Your journey now takes you to her shoulder girdle, the complex of bones that connects your arms to your skeleton. Here the team found another set of primitive features that had been lost in other human lineages. Her clavicles, the collarbones that you can feel at the top of your chest, were very short. This, combined with the shape and orientation of her scapula, or shoulder blade, would have pulled her entire shoulder assembly forward and slightly upward. The visual effect of this would have been striking. You have to imagine a person in a permanent shrug, with their shoulders hunched slightly forward, as if bracing against a perpetual chill. This arrangement didn't just affect her posture, it would have fundamentally changed how she used her arms. The specific flexible rotation of the shoulder that allows a modern human to throw a baseball at 90 miles an hour is a relatively recent evolutionary innovation. The little lady of Flores didn't have it. Her range of motion would have been more restricted, making a powerful, accurate overhand throw almost impossible. But perhaps the most conclusive piece of evidence against the sick modern human theory was found in her wrists. Your wrist is a collection of small, intricately shaped bones called carpals. The specific shape of these bones in modern humans is an adaptation for powerful gripping and fine manipulation, essential for the way we make and use complex tools. When the researchers examined the wrist bones of LB1, they found that they looked nothing like ours. They were shaped like the wrist bones of a much earlier hominin, like Lucy, the Australopithecus. In some ways, they were even more similar to the wrists of a modern chimpanzee. This is a crucial point. No known developmental disease in modern humans, not microcephaly, not Laron syndrome, can cause a person's wrist bones to revert to an ancient, ancestral, ape-like form. It's the skeletal equivalent of finding a modern car that just happens to have the engine of a Model T Ford inside. It's not a defect, it's a different design. Just how this wrist structure affected their ability to manufacture and use their sophisticated stone tools is a puzzle that biomechanics experts are still trying to solve. So now, you can step back and see the full portrait, a picture assembled from these ancient revelatory bones. You see a tiny human, no taller than a modern preschooler, standing on disproportionately large, flat feet. You see a creature moving with a high-stepping, plodding gait through the jungle gloom. You see a hunched-over figure with high, forward-set shoulders. And you see them gripping a stone tool in a hand connected to a primitive, ape-like wrist. This was not a sick or malformed version of us. This was a completely different model of human, a mosaic of ancient and advanced traits, perfectly sculpted by its long isolation on a lost island world. This overwhelming anatomical evidence should have settled the debate, but the skeptics were not so easily silenced. You've now seen the mountain of evidence for this strange new species. The rewired brain, the giant feet, the hunched shoulders, the ape-like wrists. It paints a consistent and compelling picture of a unique human. But in science, a core principle is that extraordinary claims require extraordinary evidence. And to many scientists, the claim of a brand new, tiny human species living until so recently was about as extraordinary as it gets. It's often more likely, they argued, that you found a 1 in a billion anomaly then that you've overturned the entire map of human evolution. The critics, therefore, focused on finding more ordinary explanations for this very extraordinary skeleton. Their main argument, the one you've heard before, centered on the diagnosis of severe microcephaly. You need to understand that this wasn't just a wild guess. It was a carefully considered hypothesis. Microcephaly is a real and devastating developmental condition. They presented their case almost like medical examiners. Exhibit A was the tiny skull, the most obvious parallel. Exhibit B was the short stature, a common feature in many individuals with congenital disorders. Exhibit C, they argued, could be found in the face itself. They pointed to the sloping forehead and the lack of a prominent chin, interpreting these not as primitive, ancestral traits, but as well-known symptoms of a modern human with a developmental pathology. Their conclusion was simple and powerful. The team hadn't discovered a new species. They'd found the tragic remains of a sick individual who was likely cared for by a community of normal-sized Homo sapiens. As the debate raged on, other theories from the skeptical camp emerged. Another prominent diagnosis put forward was Leang syndrome. This is a rare genetic form of dwarfism caused by the body's inability to use growth hormone. People with Leang syndrome have very short stature, but their head and brain size, while small, are often more proportional to their bodies, and their intelligence is typically unaffected. Proponents of this theory pointed out that similar genetic conditions are known to become concentrated in isolated human populations. They even highlighted a village in a neighboring part of Indonesia where a similar form of endemic dwarfism exists today. Perhaps, they suggested, Leang Bua was home to a whole population of modern humans who carried a genetic mutation that made them small, and LB1 was just one of them. For the better part of a decade, the scientific community was split down the middle. This wasn't a quiet academic disagreement. It was a passionate and sometimes personal intellectual war. The debate played out in the pages of the world's most prestigious scientific journals, with each new paper feeling like a volley in an ongoing battle. Scientific conferences became tense arenas where researchers on opposing sides would publicly pick apart each other's data. The catchy nickname, Hobbit, while great for news headlines, sometimes added fuel to the fire, making the whole affair feel less like a scientific inquiry and more like a public spectacle. The central question remained unresolved. Was the little lady of Flores a messenger from a lost world, or a tragic ghost who was simply, sadly, one of us? This scientific civil war, as fierce as it was, showcases the best of the scientific method. The skeptical arguments were not an obstruction. They were a crucible. They forced the Discovery team and their allies to rigorously test every piece of evidence and to search for more. And over the following years, new discoveries emerged from the cool, dark earth of Flores that, one by one, systematically dismantled the case for pathology. The first blow to the sickness theory came from Leang Bua cave itself. As the team continued their meticulous excavations in the layers around LB1, they began to find more remains. Not another complete skeleton, but crucial, telltale fragments. Another lower jaw, some arm and leg bones, a few teeth. These bones belonged to different individuals, as many as 9 or more, and every single one of them was tiny. The jawbone, for instance, came from an adult that was even smaller than the little lady of Flores. This was a game changer. It's plausible to find one sick individual in a population. It's even possible, though unlikely, to find a small group suffering from a localized genetic disorder. But to find a whole population of these tiny people living and dying in the same place over thousands of years, makes the disease hypothesis stretch to the breaking point. This wasn't an anomaly, it was a people. The second and perhaps most elegant refutation came from simply looking again at the anatomy you now know so well. The proponents of the pathology theory could never provide a satisfying explanation for the primitive traits. Microcephaly shrinks a modern human brain. It does not rewire it with an enlarged Brodmann area 10. Laron syndrome stunts a modern human's growth. It does not resculpt their wrist bones into the shape of an ape's. These features are not symptoms. They are deep, ancestral signals, echoes of a much older evolutionary heritage that our own lineage left behind millions of years ago. The body of LB1 wasn't a broken version of a modern human. It was a perfectly functional version of something else. The final definitive nail in the coffin of the pathology theory came not from Leang Bua, but from another site on the island, a place called Mata Menga. Here, digging in layers of ancient volcanic ash, researchers found stone tools that were dated to an astonishing 700,000 years ago. And then, in 2016, they found what they were looking for: the fossilized remains of the toolmakers. It was a fragment of a jaw and a half-dozen teeth, and they were just as tiny as their descendants in Leang Bua. This discovery was the final checkmate. It proved, beyond any reasonable doubt, that a population of tiny hominins had been living on Flores for more than 500,000 years before the little lady of Flores was even born. They existed on this island long before our own species, Homo sapiens, had even evolved back in Africa. It is therefore a logical impossibility for them to be a diseased population of modern humans. In the face of this cumulative evidence, the debate has now largely fallen silent. The overwhelming consensus in the scientific community today is that Homo floresiensis is a valid and distinct species. The process of skepticism worked. It forced the claim to be tested against every possible alternative, until only the extraordinary truth remained. And so, scholars now focus their debates not on if they were a unique species, but on the even deeper mystery of how they originated. Where did this lost tribe of the human family actually come from? With the question of their existence settled, a new, even more profound mystery took center stage. Who were they? If the little lady of Flores and her people were a distinct branch of the human family, where did that branch sprout from? The quest for their origin has led to two major competing theories, and your journey now takes you deep into the first and most widely accepted of these explanations. It's a theory that casts the hobbit not as a relic from the dawn of humanity, but as the strange and shrunken descendant of a true giant of the human story. To understand this theory, you first need to meet the proposed ancestor, Homo erectus, the upright man. You can think of them as the great pioneers of our family. Appearing in Africa nearly 2 million years ago, they were a revolutionary new kind of hominin. They were tall, some standing over 6 feet, with long athletic limbs built for marathon running. Their brains were significantly larger than anything that had come before, approaching the lower range of modern humans. They were expert tool makers, they likely controlled fire, and they were the first hominins to hunt big game systematically. Most importantly, Homo erectus was the first member of our genus with a true sense of wanderlust. They were the first to stride out of their African homeland and colonize the vast continents of Asia and Europe. Their presence in this specific part of the world is undisputed. The famous Java man fossil, discovered in the 1890s on the Indonesian island of Java, is a classic example of Homo erectus. The evidence places them in the right place at the right time. Not only were they living on the islands next door to Flores, but archaeologists have found stone tools on Flores itself at a site called Wolo Sega that date back over 1 million years. These tools are far too old to be the work of modern humans, and their style is consistent with the technology of Homo erectus. So the ancestor was in the neighborhood. The theory, then, proposes a simple, dramatic scenario. Imagine a small group of these tall, clever, adventurous hominins living on the coast of a nearby island. A powerful tsunami, a common event in this volatile, volcanic region, sweeps a chunk of the coastline out to sea, carrying the terrified group with it on a natural raft of tangled trees and vegetation. Days later, they wash ashore on the alien island of Flores. They are trapped. Once stranded, the inexorable logic of the island rule, the one you saw applied to the elephants, takes hold. For a creature like Homo erectus, a large body and a big brain are incredibly expensive. A human brain, remember, consumes about 20% of your body's total energy. On the mainland, that's a worthy investment for outsmarting rivals and prey. But on Flores, with its limited food and lack of major predators, this expensive hardware becomes a burden. Generation after generation, the same selective pressures that shrank the Stegodon would have favored the smaller Homo erectus individuals. Smaller bodies and smaller brains required fewer calories and were more efficient. Over hundreds of thousands of years of isolation, the giants shrank. Their bodies dwindled, and their brains, the most energy-hungry organ of all, shrank dramatically along with them. They became Homo floresiensis. This theory is supported by more than just logic. Detailed analysis of LB1's skull shows that subtle features, like the thickness of the bone and the shape of her teeth, are more similar to Homo erectus than to any other hominin. She may have been a hobbit, but her great-great ancestors, many times removed, may well have been giants. The theory of a shrunken Homo erectus is neat, logical, and well supported by much of the evidence. It's the explanation you'll find in most textbooks. But as you look closer at the strange mosaic of the little lady's body, you find some pieces that just don't seem to fit. A few key features are not just a little different. They seem to come from a much, much older chapter of the human story. This has led a minority of scientists to propose a second theory, one that is far more radical and, if true, could rewrite the opening pages of our global history. To grasp this idea, you have to travel even further back in time, long before Homo erectus was striding across the plains. You have to go back to the very dawn of our genus in Africa. Here you meet creatures like Australopithecus afarensis, Lucy's species, small bipedal hominins with ape-like arms and small brains. And you meet Homo habilis, the handyman, one of the first members of our own genus, who was slightly more human-like, but still small-bodied and small-brained. For decades, the universally accepted story was that these early primitive hominins were an African phenomenon. They lived, evolved, and died out entirely on that continent. The great pioneer, the first to break the continental barrier, was the bigger, smarter, more advanced Homo erectus. But this is where the hobbit throws a wrench in the works. Remember her strange anatomy? Her ridiculously long, flat feet, lacking the arch of a modern walker? Her short, big toe? And most critically, her primitive ape-like wrist bones? These features are a terrible fit for a descendant of the tall, athletic Homo erectus, but they are a near-perfect match for the anatomy of an Australopithecus or a Homo habilis. This alternative theory argues that the hobbits didn't shrink down from a giant ancestor on the island. They were small because their ancestors were always small. The scenario this theory paints is stunning. It suggests that long before Homo erectus began its famous march out of Africa, a much earlier, much more primitive hominin also made the journey. A creature perhaps like Homo habilis, small and armed with the simplest of stone tools, somehow found its way out of Africa and against all odds trekked all the way across Asia to the shores of Southeast Asia. Some of them eventually became stranded on Flores, where they lived in isolation for 1,000,000 years, preserving the ancient body plan of their ancestors. In this version of the story, the little lady of Flores is not a dwarfed giant. She is a living fossil, a relic from the very beginning of the human journey. You can see why this theory is so controversial. It challenges the very bedrock of our understanding of early human dispersal. The Out of Africa story has a main character, and that character has always been Homo erectus. To suggest a prequel, an unknown exodus by a much more primitive player, is a radical claim. It would mean our family tree is even wilder and more complicated than we imagine, and that the ambition to explore the world is a much more ancient part of our heritage than we ever knew. It's a tantalizing, mind-bending possibility, supported by those stubborn, inconvenient bones in her wrists and feet. You've now journeyed through the two competing origin stories for our tiny human cousin. In one corner, the shrunken descendant of the great pioneer, Homo erectus. In the other, the last surviving relic of a much more ancient, unknown migration out of Africa. It's a scientific stalemate, with compelling anatomical evidence pointing in both directions. In a situation like this, scientists dream of a tiebreaker, a single decisive piece of evidence that can cut through the ambiguity of bones and settle the question for good. In the 21st century, that tiebreaker has a name: DNA. An ancient genome is the ultimate family tree. It's a biological manuscript that contains the full evolutionary history of a species. If the researchers could just extract a clean sequence of Homo floresiensis DNA, the debate would be over in a flash. They could compare it directly to the genomes of modern humans, Neanderthals, and Denisovans. They could see exactly when their lineage branched off from ours. The DNA would shout the answer. Was their closest relative the advanced Homo erectus from Asia, or a far more ancient hominin from the dawn of our time in Africa? It remains the holy grail for researchers studying the little lady of Flores, a single discovery that could instantly end the debate. There's just one problem. DNA is a ghost. It is one of the most complex molecules in nature, but it is also incredibly fragile. The moment an organism dies, its DNA begins to break apart. The long, elegant strands are attacked by water, by oxygen, and by microbes in the soil, shattering into smaller and smaller, unreadable fragments. In the perfect conditions, a deep, frozen permafrost or a cold, dry cave in Siberia, this degradation is slowed to a crawl, and DNA can sometimes survive for hundreds of thousands of years. But the warm, humid, acidic soil of a tropical island like Flores is a nightmare scenario for preservation. It is the absolute worst environment on Earth for a delicate molecule to survive. Trying to find a complete strand of hobbit DNA in the soil of Leang Bua is like trying to read a book that's been left out in a monsoon for 50,000 years. All you're left with are pulp and a few scattered letters. But the prize was so great that they had to try. You can picture the scene in the specialized, sterile labs. Scientists in full-body, clean suits, like astronauts from an inner space mission, take a tiny, precious sample from the hobbit's tooth, the part of the skeleton where DNA is best protected. They use cutting-edge technology, machines designed to hunt for and amplify the faintest, most fragmented genetic whispers from the past. They ran the tests again and again, pushing the limits of the science of paleogenomics. And the result of all this effort? Nothing. Every attempt has ended in failure. They found plenty of DNA from the soil bacteria that had colonized the bones. They found DNA from the modern researchers who had handled the fossils. But they have never, not once, found a single verifiable fragment of the ancient genome they were looking for. The ghost has vanished completely. And so, for now, the bones remain silent on their deepest secret. The ultimate answer to who they were is locked inside them, a chemical code that has faded to illegibility. We are left to read the shapes and shadows of their anatomy, to piece together their story without the help of the Book of Life itself. While the grand question of their ultimate ancestry remains locked in those silent, DNA-less bones, the story of their life is written much more clearly in the earth. The rich archaeological record at Leang Bua allows us to pivot from the mystery of what they were to the more intimate story of how they lived. So let's leave the fierce academic debates behind. Your journey now takes you back to that cool, vast cave. But you're no longer seeing it as an excavation site. You're seeing it as a home. Imagine yourself standing at the entrance as dusk falls over the Flores jungle. The air grows cooler, and the strange sounds of the nocturnal creatures begin to rise from the forest. But inside the cave, a warm orange glow pushes back against the encroaching darkness. This is not just a shelter. It is a sanctuary. Given the terrifying menagerie of predators you know are stalking the island, a solitary life out in the open would have been impossibly short. Survival here demanded teamwork. The evidence strongly suggests that the little lady and her people lived in small, cooperative groups, likely centered around close family and kinship. Their society was the essential tool that made all their other tools work. As you step closer to the firelight, a scene of prehistoric domestic life unfolds. You see a handful of them, their small, hunched figures moving in the flickering shadows cast upon the towering limestone walls. The air is filled with the smell of wood smoke and roasting meat from a giant rat sizzling over the embers. In one corner, an individual sits cross-legged, their primitive wrist and clever mind working in perfect concert. You hear the sharp, percussive clack, clack, clack as they strike a river cobblestone with a hammerstone, expertly knocking off a razor-sharp flake that will be used to butcher tomorrow's meal. Children, their large, flat feet dusty from the cave floor, might be playing a game nearby, their laughter echoing in the vast chamber. It's a scene of calm, of community, a pocket of shared warmth and safety in a deeply dangerous world. But what would you hear? What did their voices sound like? The question of their language is one of the most fascinating and frustrating puzzles of all. Unfortunately, the anatomy of speech, the larynx, the tongue, the hyoid bone that supports it, is all soft tissue that vanishes from the fossil record. We have no physical evidence to know if they were capable of the same range of sounds as us. Scholars still fiercely debate whether complex, symbolic language is a unique feature of Homo sapiens, or if other hominins, like Neanderthals, and perhaps even floresiensis, possessed their own forms of sophisticated communication. The hobbits' language may not have been like ours, full of complex grammar and syntax. It might have been a simpler proto-language, a system of grunts, calls, and tones, rich in meaning but basic in structure, woven together with an elaborate dictionary of hand gestures and body language. But whatever its form, communication was the invisible thread that held their small society together. It was the software that allowed them to coordinate a hunt, to warn of danger, and to pass their vital knowledge of tool-making and survival from one generation to the next. That complex social software of communication was essential, but to survive in the real world, you need hardware. For a species without venom, claws, or armor, survival is spelled TOOLS. The entire floor of Leang Bua cave is littered with the evidence of their technological prowess, a carpet of stone artifacts that tells the story of their ingenuity and their daily struggles. Their toolkit, which remained remarkably consistent for hundreds of thousands of years, was the key to their long reign on the island. At a glance, the tools might not look like much to you. You see a collection of sharp-edged flakes, pointed fragments, and heavy, rounded riverstones with chunks knocked off them. But in the hands of a hobbit, this was a versatile and deadly effective kit. The sharp flakes, some no bigger than your thumb, were their knives and scalpels, capable of slicing through the thick hide of a stegodon or delicately butchering a giant rat. The points could be used as awls to punch holes in leather or as drill bits. And the heavy cores, the rocks from which these flakes were struck, made for powerful choppers, perfect for smashing through joints or cracking open bones to get at the rich, fatty marrow inside. It was a simple, portable, and highly adaptable toolkit. But here's where the puzzle gets deeper. Archaeologists classify this style of tool, a core and the simple flakes struck from it, as Oldowan-like. To understand the significance of that label, you have to know that the Oldowan industry is the oldest and most basic tool technology known to humanity. It's what our ancestor Homo habilis, the handyman, was making in Africa over 2.5 million years ago. Now, consider the hobbit's proposed ancestor, Homo erectus. By the time they were roaming the globe, they had long since graduated from this basic technology. They were the inventors of the Aculean hand axe, a far more sophisticated tool. A hand axe is a symmetrical, teardrop-shaped, bifacial tool, meaning it's carefully worked on both sides to a sharp edge. It requires forethought, a clear mental template, and dozens of precise strikes to create. It is a significant cognitive and technological leap, beyond a simple Oldowan flake. So you're faced with a conundrum. If the hobbits descended from the technologically advanced Homo erectus, why were they using the Stone Age equivalent of a Model T Ford? Why the apparent technological step backward? This puzzle has sparked a fascinating debate among archaeologists. On one hand, you have the theory of technological regression. Perhaps, as their brains and bodies shrank in the isolated island environment, their culture also simplified. They may have lost the complex knowledge required to make a hand axe, a kind of collective amnesia settling over the generations. Or perhaps there is a much cleverer explanation. Maybe they didn't need hand axes. Maybe the simple, easy-to-make flake and core tools were perfectly and optimally suited for the tasks they faced on Flores. A lightweight flake is much easier to carry than a heavy hand axe, and you can make a new one in seconds whenever you need it. Why spend hours crafting a fancy axe when a simple disposable razor blade will do the job of butchering the local fauna just as well? This is the less is more argument. It suggests that their simple tools weren't a sign of a simple mind, but rather a sign of remarkable efficiency and adaptation to their unique world. They didn't regress, they optimized. That simple toolkit, perfectly optimized for the island, was not for show. It was for survival. The ultimate proof of its effectiveness and of the complex mind that wielded it is found written in the bones of their prey. Let's leave the relative safety of the cave now and follow a small hunting party as they move silently through the dense jungle. You are a hidden observer, watching a scene that played out on this island for 1,000 generations. The air is heavy, and the ground is damp underfoot. The hunters, a small group of 3 or 4 adults, move with that strange, high-stepping gait that you now recognize, their large, flat feet giving them a stable purchase on the gnarled roots and slick mud of the forest floor. Their target is the most prized and dangerous game on Flores, the Stegodon. You see a small herd of the dwarf elephants in a clearing ahead, their pig-sized bodies moving through the ferns. They are powerful, muscular creatures with short tusks, and even a dwarfed elephant is a formidable force. A direct confrontation with a healthy adult would be suicide. The hunters are patient. They are not watching the big bull or the protective mothers. Their eyes are fixed on a juvenile, one that seems a bit clumsy, a bit slow, and has wandered a little too far from its mother's watchful eye. Whether they hunted the adults or, as the evidence seems to suggest, specialized in opportunistically targeting the young, sick, or trapped individuals is a matter of ongoing research. But today, their strategy is clear. You watch as the leader of the small group gives a series of silent hand signals. There is no spoken language to spook the prey, only a complex and clearly understood choreography of gestures. One hunter peels off to the left, another to the right, circling wide through the undergrowth. They are not just hunters, they are strategists, using the landscape as their primary weapon. They are maneuvering the young Stegodon towards a narrow, muddy ravine, a natural trap. The whole operation is a testament to the power of that enlarged Brodmann Area 10 you learned about. This is forward planning in action. The moment comes. The young elephant, now separated from the herd and confused, stumbles into the muddy patch of ground. Its feet sink, its movements become slow and panicked. And then, the hunters strike. They emerge from the shadows, not with a wild charge, but with a focused and deadly purpose. In their hands are stout wooden spears, their tips armed with the wickedly sharp stone points you saw them making back at the cave. They move in with a courage that is hard to comprehend, darting in to stab at the animal's flanks and underbelly, then retreating before the panicked beast can trample them. It's a dance of incredible risk and precision. One slip, one moment of hesitation could be fatal. But they work as a seamless unit, their actions coordinated by a shared understanding of the plan. Finally, the young Stegodon collapses. The hunt is over. The silence that follows is broken only by the hunter's heavy breathing. You are witnessing the single greatest testament to their intelligence. This scene, the silent communication, the strategic use of the terrain, the sophisticated tool use, and the raw courage, is the ultimate rebuttal to anyone who would dismiss them as simple-minded. The reward for this immense risk is life itself. The fallen elephant is a mountain of meat, enough to feed the entire group back at the cave for weeks. It's a bounty of protein and fat, and its hide and bones will provide the raw materials for a dozen other needs. This was not just a meal, it was a future. The successful Stegodon hunt you witnessed was an incredible event, a moment of high drama and immense reward that would be celebrated back at the cave. But you must understand, an event like that was the exception, not the rule. It was a festival, a windfall. No species can survive by relying solely on rare, high-stakes encounters. The true secret to the Hobbit's million-year success story is not found in the epic, but in the everyday. Survival is a daily grind, a constant, patient search for calories, and for that, they turned to the island's more reliable, if less glamorous, offerings. If you were to sift through the bone-rich layers of the Leang Bua cave floor, the remains of the dwarf elephant would be relatively rare. What you would find in astonishing numbers, piled up in ancient garbage heaps over millennia, are the bones of rats. Specifically, the giant Flores rats, the dog-sized rodents that you met earlier. For the hobbits, these were not pests. They were prey. The archaeological evidence is overwhelming. The cave is filled with the remains of tens of thousands of these creatures, and their bones are covered in the telltale signs of human activity. The fine cut marks from stone flake knives used for skinning and butchering, and the blackened scorch marks from being roasted over a fire. For the little lady and her people, giant rats were the dietary staple. They were the equivalent of our chicken, a reliable, abundant, and relatively easy-to-catch source of protein. Hunting them would have required a different skill set than the brave confrontation with a Stegodon. It would have been a game of cunning and stealth. You can imagine them setting simple but effective snares along rodent trails, or working together to drive a rat out of a hollow log. It required an intimate knowledge of the animal's habits, its burrows, and its behavior. It was a quieter, but no less intelligent form of hunting. But their menu was far more varied than just elephant and rat. The people of Flores were the ultimate opportunists. They ate what the island provided. The bone record shows they also dined on frogs, snakes, lizards, and any birds they could catch, likely raiding nests for their eggs as well. They were not picky eaters. If it moved, and they could subdue it, it was probably considered food. This flexible approach is a hallmark of a successful, resilient species. And of course, we've only been talking about the meat. The exact proportion of their diet that came from meat versus plants is impossible to know for certain, as plant matter rarely fossilizes. But their flexible approach to food is undeniable. It's almost certain that a huge part of their daily calories came from foraging. You can picture them moving through the forest, armed with an immense mental encyclopedia of the local botany. They would know which gnarled root was a starchy, energy-rich tuber, which fruits were sweet and safe, and which brightly colored berry would bring sickness or death. This knowledge, passed down through generations, was just as vital as any stone tool. Theirs was not a life of specialized big-game hunting, but a rich and varied subsistence, a testament to their ability to wring a living from every corner of their strange, isolated world. This flexible, opportunistic diet was one half of the survival equation. The other half was much more primal. Don't get eaten. For all their intelligence and ingenuity, the hobbits were small creatures in a world that had evolved giant predators to fill its empty niches. They were not at the top of the food chain. Every trip out of the safety of Leang Bua was a calculated risk. A journey into a landscape where death could strike from any direction, including from the sky. Imagine you are with a young hobbit, perhaps foraging for edible roots at the edge of a small clearing. The work is focused, your eyes on the ground. But a sudden change in the quality of the light makes you look up. A shadow has fallen over you. A shadow so large and sharp-edged, it seems to have blotted out the sun. You freeze. Standing at the far side of the clearing is a feathered nightmare. It is Leptoptelos robustus, the giant marabou stork of Flores. You have to erase from your mind any image of a graceful, elegant bird. This is a 6-foot-tall avian undertaker, standing on 2 long, spindly legs. It has a huge cloak-like wingspan that stretches 12 feet from tip to tip, and its head is bald and reptilian. Its most terrifying feature is its beak, a massive sharpened club, 1.5 feet of solid bone like a sharpened railroad spike, designed for stabbing and crushing. This creature, standing at its full height, would have stared down at an adult hobbit. To understand the threat, you only need to look at its smaller, modern-day relatives in Africa. Marabou storks today are primarily scavengers, but they are also ruthless and opportunistic predators. They will stalk and kill animals as large as adult flamingos, swallowing them whole. The fossil evidence from Flores suggests that the giant stork was even more formidable, with thicker, heavier leg bones, indicating it spent most of its time on the ground, striding through the forests like a true terrestrial predator. Paleontologists still debate the exact hunting style of Leptoptylos robustus. Was it a patient ambush predator or an aggressive stalker? But its potential threat to a small hominin is undeniable. Back in the clearing, the giant bird takes a slow, deliberate step towards you. Its black, beady eyes are fixed on you with a cold, unblinking intelligence. There is no escape in a direct race. The bird's stride is too long. Your only hope is the chaotic terrain. You scramble, your heart pounding, not for the open forest, but for a dense thicket of thorny vines nearby. You dive into the tangled mess just as that colossal beak stabs down at the spot where you were a second before, striking the earth with a heavy, sickening thud. The bird probes the thicket, its beak jabbing and snapping, but it can't get through. Eventually it gives up and stalks away with a frustrated rustle of its huge wings. You stay hidden, listening until you are sure it's gone. This encounter is a brutal lesson. The world is full of monsters, and the high stone roof of Leang Bua is not just a shelter from the rain. It is a fortress, an essential shield against the ever-present death from above. The terror from the sky was a constant worry, but the undisputed king of Flores, the apex predator that ruled the island's forests and grasslands, was a monster that walked the earth. It was a creature that seems to have slithered directly out of mythology, a living dragon. You are, of course, meeting Varanus komodoensis, the Komodo dragon. These are not just lizards. They are the largest and heaviest lizards on the planet, a relic from an age of giants. Imagine a 10-foot-long, 200-pound behemoth built low to the ground on 4 powerful clawed legs. Its skin is not smooth, but a rough, armored hide, like a suit of natural chainmail. Its yellow forked tongue flicks in and out, tasting the air for the scent of its next meal. The true terror of the dragon lies in its mouth. For millennia, scientists debated whether its lethality came from a toxic brew of bacteria in its saliva or true venom. It's only in the last couple of decades that the evidence for sophisticated venom glands, hidden in its lower jaw, has become undeniable. When a Komodo dragon bites, it delivers a devastating 1-2 punch. First, its teeth, which are serrated like a shark's, inflict a catastrophic wound, tearing through flesh and muscle. Then, its venom seeps into the wound. It's a complex chemical cocktail designed to send the victim into shock and, most critically, to stop the blood from clotting. The dragon's hunting style is one of patient, terrifying efficiency. It does not need to be fast. It doesn't need to wrestle its prey to the ground. It only needs to land one good bite. It is an ambush predator. It will lie in wait for hours, perfectly camouflaged, until a pig, a deer, or a dwarf elephant wanders past. Then a sudden lightning-fast lunge, a single tearing bite, and the dragon retreats. The wounded animal stumbles away, but it is doomed. The dragon simply follows at a leisurely pace, its forked tongue tasting the trail of blood, waiting for shock and blood loss to do their inevitable work. It might take hours. It might even take days. But the hunt only ever has one ending. Now, imagine you are with a hobbit foraging party, making your way back to the cave. You come to a clearing, and the smell of blood is thick in the air. You peer through the bushes and see a sight of primal horror. A massive Komodo dragon is on a fresh kill, a juvenile Stegodon. The dragon is a whirlwind of savage efficiency, tearing out chunks of flesh, its powerful neck muscles ripping the carcass apart. For the hobbits, this is a moment of supreme danger and frustrating temptation. The meat could feed them for a month, but the dragon is the absolute master of this kill. To challenge it would be madness. The hunters know this. There is a reason this creature is a dragon, and not just a lizard. It is a force of nature, a power on this island that is not to be confronted, only to be avoided. They give the scene a wide, respectful berth and hurry on their way, a lesson in humility and fear, reinforced once more. The most chilling fact of all? The fossilized remains of Komodo dragons have been found inside Leang Bua cave. This means that man and monster were not just neighbors. They were roommates. They sought shelter in the very same spaces, perhaps at different times, perhaps even overlapping. You have to imagine the hobbits, huddled around their fire, knowing that in the deeper, darker recesses of their own home, a dragon might be sleeping. You've now met the monsters. You've looked up at the 6-foot killer stork and stared into the cold eyes of the Komodo dragon. These were the spectacular, headline-grabbing predators of ancient Flores. But a dangerous world is dangerous in its details. The threats were not confined to the island's giants. Peril was a constant companion, woven into the very fabric of the landscape, from the shimmering coastlines to the darkest corners of the forest floor. Imagine your hobbit group, perhaps driven by hunger, venturing down from the relative safety of the inland hills towards the coast. You see the sparkling ocean, and you know the riches it holds. The tidal flats and reefs are a seafood buffet of crabs, shellfish, and fish trapped in shallow pools. It should be an easy living, but as you approach the mangrove swamps that fringe the coast, you see the guardians of this bounty. Lying half-submerged in the brackish water, looking for all the world like a floating log, is a saltwater crocodile. This is the largest reptile on Earth, a 20-foot-long armored torpedo of muscle and teeth. They are masters of the ambush, capable of exploding from the water to drag their victims in, finishing them with their terrifying death roll. This immense danger would have effectively sealed off the coast. The easy meals of the sea were locked away, forcing the hobbits back into the more challenging interior of the island. So you retreat back into the jungle, but the dangers here are more subtle, more insidious. You are walking through the dense undergrowth, where the light is dim and the leaf litter is thick. You have to watch every single step you take. You have to check every branch before you grab it for support, because the forest is teeming with venomous snakes. You might encounter the Javan spitting cobra, which can blind you from a distance before it even strikes. You might disturb a Russell's viper, a perfectly camouflaged ambush predator with a potent, fast-acting venom. A single careless moment, a foot placed in the wrong spot, could result in a fatal bite, far from the help of your family in the cave. This was a world that demanded constant, moment-to-moment vigilance, and even the non-venomous snakes were a mortal threat. This is the home of the reticulated python, one of the longest snakes in the world. A large adult, stretching over 20 feet, is a silent and powerful constrictor. While there is no direct fossil evidence of a hobbit being eaten by a snake, the ecological reality is that any small, ground-dwelling mammal of that size would have been a potential prey item for a large python. It's yet another ambush predator to worry about. A silent hunter that could drop from a tree or strike from the riverbank without warning. You must understand, then, that Flores was no tropical paradise. It was an island of horrors. Every venture for food was a journey through a gauntlet of giant birds, dragons, crocodiles, and venomous snakes. Survival was a daily miracle, a testament not just to their clever tools, but to their deep knowledge of the environment, their constant watchfulness, and the unbreakable bonds of cooperation that held their small groups together. To have thrived in this place for nearly 1 million years is one of the most incredible survival stories in all of human history. But eventually, a new creature would arrive on the island, a creature more dangerous and more disruptive than all the others combined. You have now walked a day in their giant, flat footsteps. You have seen the world through their eyes, a landscape of dwarfed giants and monstrous predators, a world of constant, nerve-wracking peril. Surviving a single week here would be a challenge for a modern, well-equipped human. The fact that Homo floresiensis thrived here for a span of time that makes all of recorded human history look like a fleeting moment is staggering. It forces us to go back to that central question of their tiny brain and ask a more fundamental question. What is intelligence? Is it measured by the size of the brain and the complexity of its tools, or by the simple, irrefutable metric of long-term survival? By that second measure, the hobbits were geniuses. Theirs was not an abstract philosophical intelligence, but a deeply practical, environmental one. It was the intelligence of knowing which mushroom would kill you and which would feed you. It was the intelligence of reading the subtle signs of the forest to know where a Stegodon had passed, or where a Komodo dragon might be lying in wait. It was the intelligence of understanding the physics of a stone to know exactly where to strike it to produce a perfect, razor-sharp edge. And perhaps most importantly, it was the social intelligence to hold a family group together, to communicate complex plans, to share food, and to protect one another in the face of overwhelming danger. Look at their toolkit again. In the grand scheme of human technological evolution, their simple Alderaan-like flakes and choppers seem primitive. But after seeing their world, you can see them in a new light. This was not a failure of imagination, it was a triumph of optimization. In an environment with no need for armored opponents or massive game, why invent a cannon when a well-aimed slingshot will do? Their technology was minimalist, efficient, and disposable. They could create a complete, life-saving toolkit from a handful of river pebbles in a matter of minutes. This wasn't a sign of cognitive limitation. It was a sign of being perfectly adapted to a stable world that required no major technological upgrades. You can think of it like this. The hardware of their brain was small, but the software of their culture, their knowledge, and their social strategies was incredibly powerful and refined. They are a powerful testament to the fact that there are many different ways to be human, many different forms that intelligence can take. They had solved the unique and brutal evolutionary puzzle of Flores. For nearly 1 million years, they were the undisputed masters of their lost world, a perfectly balanced and successful species. They had faced down dragons and giant storks. They had hunted elephants, and they had carved out a permanent home for themselves in a world that seemed designed to kill them at every turn. They were the ultimate survivors. But the greatest test of their resilience was yet to come, and it would arrive on the tide, walking on 2 long legs. For 900,000 years, the world of the hobbits had been a stable, predictable place. The rules of the game, as brutal as they were known. The storks hunted from above, the dragons from the ground, and the hobbits, with their intelligence and cooperation, had found the perfect strategy to not only survive, but to thrive. They were the island's people, its sole keepers of fire and stone tools. Their reign had lasted for a length of time that is almost impossible for our minds to grasp. Then, sometime around 50 or 60,000 years ago, everything changed. A new animal arrived on Flores, and this one was unlike any other. Imagine you are with a hobbit hunting party, moving along a ridge that overlooks the sea. Your eyes are scanning the forest for prey, but a strange movement on the water catches your attention. It's not a log, it's a simple raft or a dugout canoe, and on it are figures. As they guide their craft to the shore and step onto the beach, your mind struggles to process what you are seeing. They look like people, but they are impossibly, terrifyingly tall. They are giants. These are the first Homo sapiens to arrive on Flores, your direct ancestors. They are part of the great coastal migration that was, at that very moment, carrying humanity out of Africa, across Asia, and towards the new continent of Australia. From your hiding place, you watch them. They are nearly double your height, with long, slender limbs and a strange, springy way of walking. They carry themselves with a confidence you've never seen before. Their technology is different, more complex. Their spears seem longer, more refined. Perhaps one of them spots a bird in a tree, and with a flick of the wrist, hurls a spear with a speed and accuracy that your hunched-over shoulders could never hope to match. They might be adorned with necklaces of shells or patterns of ochre painted on their skin, signs of a symbolic, artistic world that is completely alien to you. Their voices are different, a complex cascade of sounds that is clearly a sophisticated language. You watch them, and you feel a profound sense of unease, a deep, instinctual understanding that the world has been fundamentally altered. For 1,000,000 years, you have been the only thinkers on this island, the only ones who make tools and control fire. You were the people. Now you are not. The exact nature of the first interactions between these two human species is, of course, lost to time, and can only be a matter of reasoned speculation. It might not have been immediately violent. It might have been driven by curiosity, confusion, or fear on both sides. But the archaeological record is clear on one point. When we arrived, they vanished. This moment, this arrival of the tall, strange people from across the sea, was the beginning of the long goodbye for the people of Flores. The 1,000,000-year reign of the ultimate survivors was about to come to an end. The arrival of the tall newcomers marks the beginning of the final act in the Hobbit's long story. The central question is no longer how they lived, but why they died. The timing is too perfect to be a coincidence. For nearly 1,000,000 years they endured, but within a few thousand years of our ancestors setting foot on Flores, they were gone. How did it happen? Whether their end came swiftly through violent conflict, or as a slow, tragic fading in the face of unbeatable competition, is a question the fossil record may never be able to answer. But the two main theories paint a grim picture of this prehistoric encounter. The first possibility is the more direct and brutal one, a war of extinction. You have to consider the perspective of our ancestors. When they encountered these small, strange-looking people, did they recognize them as fellow humans? Or did they see them as something else entirely? As intelligent, but ultimately alien, animals who were competing for the same territory, the same caves, and the same food. Throughout our species' history, the arrival of a new human group has often been met with suspicion and violence. It is a dark but plausible scenario to imagine that our ancestors simply exterminated the native inhabitants. it would have been a tragically uneven fight. The hobbits, at 3.5 feet tall, were powerfully built for their size, but were at a massive physical disadvantage. Their entire hunting strategy was based on ambush and close-quarters combat. Our ancestors, with their long limbs and modern shoulders, were masters of the thrown spear. They could strike from a distance with lethal force, a tactic the hobbits had no answer for. While there is no definitive archaeological proof, no hobbit skeleton with a spear point lodged in its ribs, the history of our species makes this a somber and very real possibility. But violence may not have been necessary. The second theory suggests a quieter, more insidious end. It's based on a fundamental law of ecology known as the competitive exclusion principle. The rule is simple. Two species competing for the exact same limited resources cannot coexist forever. Eventually, the more efficient species will win, and the other will vanish. Our ancestors, Homo sapiens, were and are the most efficient and adaptable invasive species the world has ever known. We arrived on Flores with a suite of advantages. Our longer legs could cover more ground. Our more advanced projectile weapons might have made us more effective hunters of the island's game. Our population may have simply grown faster, putting an unsustainable pressure on the island's delicate ecosystem. Imagine it from the hobbit's perspective. Suddenly, the herds of Stegodon are smaller and harder to find. The giant rats that were once a reliable staple are now being hunted by a new, more effective predator. The best patches of edible roots are being stripped bare. It wouldn't have been a war. It would have been a slow, grinding starvation over the course of generations. We didn't have to raise a spear against them. We just had to be better at gathering lunch. Their population, already likely small, would have dwindled, retreating to the most marginal parts of the island until, eventually, it was no longer sustainable. This pattern, of our arrival being followed by the extinction of ancient local species, has been repeated on every new continent and island we ever reached. The little lady and her people may simply have been one of the first casualties of our species' unstoppable global success. The scenarios of violent conflict or a slow, grinding competition are compelling, but the death of a species that has survived for 1,000,000 years is rarely a simple affair. It's often a story of a perfect storm, a convergence of different pressures that, together, become insurmountable. Beyond the direct impact of our ancestors, there were other, more invisible forces at play that may have sealed the hobbit's fate, the microscopic and the geologic. First, you have to consider the invisible enemies that our ancestors brought with them. For tens of thousands of years, Homo sapiens had been migrating across the connected continents of Africa and Asia, living in larger groups, and building up immunities to a whole bestiary of pathogens. They carried, in their bodies, a library of viruses and bacteria to which they were well adapted. Then they arrived on Flores, an island that had been in biological quarantine for 1,000,000 years. The hobbits, in their long isolation, would have had an immune system that was completely, dangerously naive. You can see where this is going. It's a tragic story that has played out countless times in more recent human history. When European colonists arrived in the Americas, it wasn't their weapons that caused the most devastation. It was their diseases. Smallpox, measles, and influenza, to which the Europeans had some resistance, tore through the indigenous populations like a wildfire, killing up to 90% of the people in some areas. A similar biological catastrophe may have unfolded on Flores. A disease that was nothing more than a common cold to our ancestors could have been a lethal plague to the hobbits, spreading rapidly through their small, cave-dwelling communities. Their population could have been decimated, their health compromised, and their ability to hunt and gather crippled long before the competition for resources even became a critical issue. Now, add to this precarious situation one final devastating blow. Remember that Flores is a volcanic island, a product of the immense geological forces of the Pacific Ring of Fire. It is a land of frequent earthquakes and eruptions. The archaeological record of the island is punctuated by thick layers of volcanic ash, evidence of periodic cataclysmic eruptions that would have completely reshaped the landscape. Imagine, then, a major eruption occurring around this critical time. The sky turns black for weeks, blanketing the island in a choking layer of ash. Pyroclastic flows, superheated clouds of gas and rock, incinerate huge swathes of the forest. The rivers and water sources are poisoned. An event like this would have triggered a total ecosystem collapse. The plants would die, and the animals that fed on them, including the Stegodon and the giant rats, would starve. For the hobbits, already weakened by new diseases and struggling against a more efficient competitor, a disaster of this magnitude would have been the final knockout punch. The ultimate cause of their extinction was likely not a single event, but a cascade of pressures, creating what scientists call an extinction vortex. They were pushed by competition, ravaged by disease, and then, perhaps, hit by a volcanic winter. It was a perfect storm from which their ancient and resilient lineage simply could not escape. These are the scientific explanations for the end of their story, a cold calculus of competition, disease, and geology. But a species is not a data point. It is a collection of lives, of families, of memories. To truly understand the end, you have to try to imagine what it must have felt like to be one of the last of them, to witness the end of your entire world. Imagine the final few generations huddled in the most remote and hidden caves of Flores, their world having shrunk from an entire island to a few fearful valleys. The stories the elders tell around the dwindling fire are no longer of the great Stegodon hunts, but of a time before. A time before the tall, strange giants came from the sea. A time when the giant rats were plentiful, and the forest belonged only to them. Now the forest is a place of scarcity and fear. The familiar hunting grounds are haunted by the presence of the newcomers, who are more numerous, more successful. Picture the last family group. They are perhaps only a dozen individuals, their bodies thin, their movements weary. The laughter you imagined echoing in the great cave of Leang Bua is gone, replaced by a watchful silence. They are a ghost population, clinging to the edge of existence, carrying the weight of 1,000,000 years of ancestry on their hunched shoulders. They watch their children grow up in a world where there is never quite enough food, where the future is a tightening knot of uncertainty. And then, finally, imagine the very last one. It doesn't matter if it was a man or a woman. See them in your mind's eye, old and alone, the last speaker of a forgotten language, the last keeper of a 1,000,000-year-old fire. They might be sitting at the mouth of a small, hidden cave, looking out at a landscape that is no longer theirs. In the distance, on the plains below, they can see the smoke rising from the campfires of the tall people, a civilization on the rise, completely unaware of the ancient world that is breathing its last in the hills above them. There is no dramatic final battle, no heroic last stand. There is only a quiet, lonely fading. The last hobbit rises, their body aching with age and hunger, and retreats into the final darkness of the cave. The last fire goes out. The last voice falls silent. A million-year-old story, a unique and irreplaceable way of being human, has come to its end. The island of Flores, for the first time in an almost unimaginable stretch of history, no longer has its native people. And the new inhabitants of the world, our ancestors, never even noticed they were gone. The story should end there. It ends with the last fire going out in a cold, lonely cave 50,000 years ago. That is what the fossil record, the language of the bones, tells us. But what if the memory of a people doesn't need bone to survive? What if it can live on in a different form, a more resilient and ethereal one? What if it can survive in stories? We now leave the world of paleoanthropology and journey into a different kind of history, an oral history, passed down not in scientific journals, but in the soft murmur of voices around a village fire. Your journey takes you to the present day, to the villages of the Naj people who live in the highlands of central Flores. Here, for countless generations, parents have told their children stories to explain the world, to teach them lessons, and to warn them of the dangers of the forest. And for centuries, one of the most enduring of these stories was the tale of a strange race of creatures who once shared the island with them. They called these creatures the Ebu Gogo. The name itself is wonderfully evocative. It translates roughly to the grandmother who eats anything. It's a strange and telling combination of the familiar, grandmother suggests something human-like, if not quite human, and the voracious, eats anything, implies a wild, opportunistic creature, perhaps one without the good sense to cook its food. The legends of the Ebu Gogo were treated by the Nage as a real, if distant, part of their history. Listen to the description of these creatures as passed down from grandparent to grandchild. The Ebu Gogo were said to be small, standing only about a meter tall. They were covered in thick, hairy fur and had long arms with long, grasping fingers. The villagers said they walked with a clumsy, awkward shuffle. They couldn't speak the language of the Naj people, but would chatter among themselves in their own murmuring tongue, a sound the villagers would sometimes mockingly imitate. According to the stories, the Ebu Gogo lived in the limestone caves up in the hills, the very same kinds of caves the hobbits called home. They were a constant nuisance to the early villagers, creeping into their settlements at night to steal food. Their appetite was legendary. They would raid crops and grab anything edible they could find, often eating it raw on the spot. This is the story, a piece of local folklore, a myth used to explain the rustle in the bushes at night, a fairy tale to frighten children into behaving. A strange and remarkably specific fairy tale. For centuries, that was all it was, a strange and specific fairy tale. It was a story told by the Nage people, but it had no basis in the real world, no more than a story of goblins or elves. And then, in September of 2003, archaeologists working in a limestone cave just a few valleys away unearthed the skeleton of the little lady of Flores. And suddenly, the old story didn't sound so much like a myth. It started to sound an awful lot like a memory. Let's place the two descriptions side by side. Let's compare the creature from the folklore with the creature from the fossil record. The legend says the Ebu Gogo were small, about a meter tall. The science, calculated from the femur of LB1, shows that Homo floresiensis stood at almost exactly 1 meter tall. The legend says the Ebu Gogo walked with a clumsy, awkward, shuffling gait. The science, based on the biomechanical models of their long, flat, archless feet, reconstructs a clumsy, inefficient, high-stepping gait that would have looked incredibly awkward to a modern human observer. The legend says the Ebu Gogo lived in caves up in the hills. The science confirms that the home of Homo floresiensis, their sanctuary and graveyard for tens of thousands of years, was a cave up in the hills. The legend says they murmured to each other in their own strange language that the villagers could not understand. The science, given their small and uniquely organized brain, suggests they would have had a form of communication, but it is highly unlikely to have been a complex syntactic language like our own. It would have sounded like murmuring. The legend gives them the name the grandmother who eats anything, describing them as opportunistic pests who would steal crops and eat food raw. The science from the vast and varied bone collection on the cave floor paints a picture of the ultimate opportunistic omnivore, a creature that ate everything from giant rats to dwarf elephants. The parallels are not just vague, they are precise, specific, and utterly astonishing. And you have to remember the most crucial fact of all. These legends were written down by ethnographers and anthropologists long before the first hobbit bone was ever pulled from the ground. This is not a case of the myth being influenced by the science. It's a case of science discovering a fossil that seems to have walked directly out of the pages of folklore. So you are left with a question that is as profound as it is mind-bending. Could a story survive for 50,000 years? Could the memory of an encounter between two different human species be passed down, from grandparent to grandchild, through 2,000 generations, surviving the rise and fall of empires, the birth of religions, the invention of writing, and the dawn of the modern age? Could the whispers of the Ebu Gogo, still told in the villages of Flores today, be the last, faint, living echo of a lost human world? This astonishing possibility, that an oral tradition could preserve the memory of another human species for 50,000 years, is as controversial as the original Hobbit discovery itself. It's a debate that pits the compelling power of narrative coincidence against the rigorous skepticism of historical science. It's a question that pushes the boundaries of what we can ever hope to know about the deep past. On one side of the debate, you have scholars like the anthropologist Gregory Forth, who have spent their careers documenting these stories. The argument for the connection is straightforward and powerful. The coincidences are simply too many and too specific to be dismissed. Cultures all around the world have myths of wild men of the woods, from the Yeti of the Himalayas to the Sasquatch of North America. But these are usually vague descriptions. The Ebu Gogo legend is a detailed police sketch. It specifies a height, a gait, a habitat, a language, and a behavior that all align, with startling precision, with the fossil evidence found in a nearby cave. For the proponents of this theory, to call this a coincidence is to ignore the evidence of a living, breathing cultural fossil. The legend gets even stranger, with some local accounts claiming that the Ebu Gogo were not creatures of the deep past, but were still being sighted as recently as the 19th century, before the villagers finally wiped them out. Could a tiny relict population have survived, hidden in the deepest jungles, far longer than the bones suggest? It's an extraordinary, almost unbelievable thought. On the other side of the debate is the voice of scientific skepticism. This argument is less romantic, but it is grounded in what we know about how memory and stories work. The first point is that the Ebu Gogo could simply be the Flores version of that universal wild man myth, and its similarities to Homo floresiensis are a complete, if mind-boggling, fluke. The second, more powerful argument is that oral tradition is simply not a reliable hard drive for history over such an immense timescale. 50,000 years is not just a long time. It's an almost incomprehensible chasm. It's 2,000 generations of people. Stories passed down orally are like a message in a game of telephone. They inevitably change, morph, and absorb new details. The idea that any story could survive that journey with its key factual details intact is, for most historians, a deeply improbable fantasy. In the end, this is a mystery that science cannot solve. There is no test we can run, no bone we can analyze, that can prove the link between a fossil and a folk tale. We are left stranded at the crossroads of science and myth, of evidence and belief. You can choose to be the skeptic, to see the story of the Ebu Gogo as a fascinating coincidence and nothing more. Or you can choose to be the romantic, to believe that the human capacity for memory is far greater than we imagine, and that in the bedtime stories of a few remote villages, the last faint whispers of a lost human species have managed to survive against all odds to the present day. And so, we leave the mystery of the Ebu Gogo hanging in the humid Flores air, a perfect, unprovable echo of a scientific fact. We have traveled through the entire story of the little lady of Flores, from the first discovery in a dusty cave, through the fierce scientific battles over her identity, through the terrors and triumphs of her daily life, and to the sad, inevitable silence of her extinction. So what do we do with this story? What is the ultimate legacy of this tiny, lost member of our human family? The answer is that her discovery didn't just add a new name to the list of fossils, it fundamentally and forever changed our understanding of our own story. For 100 years, the popular image of human evolution was a simple, linear progression. You know the one. It's the famous March of Progress illustration. A stooped, ape-like creature slowly stands upright, becoming a brutish caveman, then a slightly less brutish one, and finally, the heroic, spear-wielding figure of a modern Homo sapiens at the end of the line. It's a clean, inspiring story of a steady, inevitable climb towards perfection. Us. The little lady of Flores, with her tiny brain and her primitive wrists, took a hammer to that beautiful, simple, and completely wrong idea. She proved, in the most dramatic way possible, that the story of human evolution is not a straight line. It is a dense, tangled, branching bush. Evolution is not a ladder. It's a series of wild experiments. For millions of years, this bush of humanity produced many different flowers, many different kinds of people who walked the earth at the same time. The discovery of the hobbit was a stark reminder of a profound truth. For the vast majority of our species' existence, we were not alone. Take a snapshot of the world, say 60,000 years ago. In the cold grasslands of Europe, our stout and powerful cousins, the Neanderthals, were hunting mammoths. In a cave in the Altai Mountains of Siberia, another group, the mysterious Denisovans, were living a life we are only just beginning to piece together from fragments of their DNA. In Africa, our own direct ancestors, Homo sapiens, were on the cusp of their global takeover. And there, on a remote Indonesian island, was a completely different experiment in humanity. The tiny, resourceful, and incredibly resilient Homo floresiensis. This was the normal state of affairs. A world of many humans. A planet of people. Our current situation, with just one single solitary human species left, is the strange and recent exception. The greatest legacy of the little lady of Flores is this lesson in humility. She reminds us that our way of being human is not the only way, and it was certainly not the inevitable one. We are just one branch of that great tangled bush, a branch that, through some combination of skill, luck, and aggression, managed to survive while all the others withered away. She forces us to look in the mirror and realize that our solitude was not a given. It was an outcome, and it left the world a much less interesting and much less human place. Her story, then, is a profound lesson. It reminds us that our world was once so much richer in its humanity. But the little lady of Flores offers us one final gift, one final piece of wisdom. Her story proves that the book of our shared past is far longer and more complex than we ever imagined, and that we have, in truth, only just begun to turn its pages. The story of Homo floresiensis is not over. It's simply the end of the beginning. Right now, as you lie there listening, new teams of scientists are planning their next expeditions to Flores. The great cave of Leang Bua has not given up all its secrets, and there are hundreds of other unexplored caves dotting the island's rugged landscape. With each passing year, the techniques of archaeology and genetics become more and more sophisticated. The quest for that ghostly DNA, a quest that has so far ended in failure, is a perfect example. The technology to sequence the Neanderthal genome, something that won a Nobel Prize, was considered science fiction just a few decades ago. It is not impossible to imagine that in the near future, a new technique will be invented. A new method that can finally read the faded chemical whispers in those ancient bones and solve the great mystery of their origins. And perhaps the most exciting realization of all is that the hobbit was not a bizarre fluke, not a one-off evolutionary curiosity. In 2019, on the island of Luzon in the Philippines, scientists announced the discovery of yet another lost human species, Homo luzonensis. It was a remarkably similar story, a small-bodied hominin living on an isolated island with its own unique mosaic of ancient and modern traits. The discovery proved that the evolution of these island people was not a singular event, but a recurring pattern in the vast, isolated archipelago of Southeast Asia. It leaves you with a final wondrous thought to drift off with. How many other islands are out there? How many other lost cousins, each with their own million-year story of survival, are still lying dormant beneath the jungle floor, waiting for a lucky monsoon to expose a bone or a curious scientist to sink a trowel in just the right place? The human family tree is far grander than the version we were taught in school. Its roots are deeper, its branches more tangled, and many of its most fascinating offshoots are still shrouded in mystery. The little lady of Flores was the first to step out of those shadows and introduce herself, a tiny ambassador from a lost world, reminding us that the greatest adventures in understanding our own past are still ahead of us. And so, our long journey to the island of Flores comes to a gentle close. The echoes of the hunt, the flickering of the ancient fire, and the murmur of the Ebu Gogo now begin to fade, leaving behind only the quiet stillness of your own room. Let the sense of deep, geological time settle over you, a comforting blanket that puts our own small, fleeting worries into their proper perspective. The story of the hobbits is a story of incredible resilience, but it is also a story of an ending, of a quiet fading into silence. And in that silence, there is a peacefulness, a sense of a cycle completed. All of those struggles, all of that striving, all of that life has come to rest, and so now can you. Feel the weight of your own body as it sinks deeper into comfort, and let your breathing slow to match the gentle, timeless rhythm of the world outside your window. The mysteries of the past are vast and deep, but tonight they can wait. Tonight is for rest, for release, for the quiet, dreamless, and well-deserved peace that comes at the end of a long journey. The story is over now. It's time for you to drift away.